All right, so in this next section, we're still doing more inverses, okay? So they want us to create a table. So what's true about inverse? You just switch them. 1, 3, 5, 7. Okay, that's not that big of a deal. The hard part might be what the heck is the equation? And I'm going to say it's a line. Hopefully it is, because that's what I'm going to focus on. So I just go like this. I don't want to focus on negatives. So I go times 2. Well, that would have to be plus 1. Times 2 plus 1. That doesn't work. So then I try times 3. Well, if I multiply by 3, I'd have to subtract 2. But if I multiply by 3 and subtract 2, that doesn't work. So all these things don't work. So I'm going to try subtracting 6, because I did it before, and subtract 11. And, wait, no. Wait, 18. Yeah, 11. So then I go times 6 is 30 minus 11. Oh my gosh, I finally got it. So that means f of x equals 6x minus 11. A lot of guess and check, okay? There's probably a way fancier way to do it, but that's what works for me. So, oh, I'm silly. You know what I could have done? Silly me, I only talked about patterns. This I could have gone plus 12, and this I could have gone plus 2. What's 12 divided by 2? 6. Ugh, there's the pattern. Okay. Sometimes it takes me a second. So if I'm going to do the f inverse of that, let's think about it. I have an x. I multiply it by 6 and subtract 11. So what's going backwards? Adding 11 and dividing by 6. Adding 11, dividing by 6. Well, let's see. Negative 5 plus 11 is 6 divided by 6 is 1. 31 plus 11 is 42 divided by 6 is 7. I'm amazing. Okay, so I just want you to get really good at doing inverses. All right, so if I'm going to do the inverse, okay, what do I do first? Subtract 1, cube it, multiply by 2. So what does that mean I do in the inverse? The first thing I'm going to do, instead of multiplying by 2, I'm going to divide by 2. I'm going to cube root it, and I'm going to add 1. So I take my answer, I divide it by 2, I cube root it, and I add 1. Hopefully I'm doing it right. How could I check it? I could pick a point. So I'll pick the point 1 for my f of x. 1 minus 1 is 0. Anything times 0 is 0. So then I should be able to do 0, 1, and maybe it should work. 0 divided by 2 is 0. The cube root of nothing is nothing, plus 1 is 1. Maybe I got lucky. Let's check. 2. 2 minus 1 is 1. Cubed is 1 times 2 is 2. Okay, well that's kind of annoying because it's 2, 2. It might be too easy, but whatever. Or not easy, but hard to really find out. 2 divided by 2 is 1. The cube root of 1 is 1 plus 1 is 2. I'm pretty sure I'm good. All right. F inverse. The first thing I did was subtract 9, then divided by 2, then multiplied by 3, and then added 20. So some of you go, okay, what do I do then? Subtract 20, divide by 3, multiply by 2, and add 9. So, subtract 20, divided by 3, multiplied by 2, add 9. All right, let's pick a number. What number do you think I'm going to pick right here that I know will more easily give me the answer? Well, I'm going to pick a 9. Because 9 minus 9 is 0 over anything is 0 times anything is 0, 20. So then 29. I mean, I got to be really off if I got this one wrong. 20 minus 2 is 18. Divided by 3 is 6. Times 2 is 12. Wait, hold on. 20 minus 2 is 18 divided by 3 is 6. Times 2 is 12. Oops, okay, hold on one second. Some of you probably saw my mistake. Subtract 20, not subtract 2. 20 minus 20 is 0. Divided by anything is 0 times anything is 0 plus 9 is 9. I'm amazing. Great to check. Now what they're saying is, okay, this time I want you to take f, which is this, and I want you to plug it in to the x there. So that means this is going to go right in there. I'm going to go more slowly on this. So I'm going to go the cube root, but instead of writing x, I'm going to write all of this. So I'm going to go 2 times x minus 1 cubed. Then divided by 2, and then plus 1. So I'm going to try simplifying that now. We'll do more of this, okay? Hold on. Cool. Well, what's 2 divided by 2? Ah, that's 1. If I have x minus 1 cubed, and I have the cube root, what's true about the cube and the cube root? They cancel. And now I'm left with x minus 1 plus 1. And what's negative 1 plus 1? X. That reminds me of y equals x. That's how I know it's the inverse. And some of you go, what? Okay, let's do this one. Let me zoom out a little bit. Actually, I think I want to do a more simple one, so let me find a more simple one that we've done before. Here, okay, this one. So this one, I'm going to test out this one because I'm sure some of you are overwhelmed. If this is f of x equals 1/2 x plus 3, and the inverse that we got was 2 times x minus 3. What they're saying, let me zoom out a little bit, is that if you take this and you plug it in there, everything should cancel out. Okay? So let's find out. So that means what I'm going to do is I'm going to rewrite this as 2 parentheses. But instead of writing x, I'm going to write 1/2 x plus 3. Then I'm going to write minus 3. Okay? So now if I simplify that, 3 minus 3 is gone. I'm left with 1/2 x times 2. Half of 2 is 1x, which is x. Y equals x. I did the inverse correctly. Okay? So now let's go back to the more difficult one. I'm not saying that one was easy, but that was an easier one. So they want you to take this, and they want you to plug it right in there. So let me zoom a little bit. So I'm going to write the 2, parenthesis, over 3 plus 9. But instead of writing x, I'm going to go 3 times x minus 9 over 2 plus 20. And then I have to subtract 20. Okay, let me make that bigger now. So this was the f of x. So now I look here and I go, oh, well, what's 20 minus 20? Gone. What's 3 over 3? Gone. So I'm left with 2x minus 9 over 2 plus 9. Well, what happens when I have a 2 on top and a 2 on bottom? Gone. X minus 9 plus 9, gone. X, y equals x. Now you know that you're good to go. All right, let's do more practice, because this is a lot. I understand. Okay, what's the first thing you do? Subtract 3. What's the next thing you do? Square it. What's the next thing you do? Add 2. So now go backwards. And this should kind of just be a review. You should be pausing this, doing it yourself, and then just checking to make sure I didn't make a mistake. So go backwards. Minus 2, square root it, plus or minus, and add 3. F inverse of x equals, take my number, subtract 2, square root it, plus or minus, plus 3. Make sure that your radical is outside. All right. So how do I know if I did it right? What am I going to do? I'm going to take all of this, which is this, and I'm going to, actually, you know what they're saying? They're saying this time, don't put this in there. This time they're saying take this and put it in there. So this time they're saying, hey, take all of this and put it in that little spot right there. So I'm going to go minus 3 squared plus 2. But instead of writing x, I'm going to write the square root of x minus 2 plus 3. Well, what's 3 minus 3? Gone. What's the square root of x minus 2 squared? Gone. X minus 2 plus 2. X, y equals x. I know that I'm good to go. This is my inverse. Okay, let's do this one. What's the first thing I do? You should be doing this yourself. Subtract 2. Next thing, square rooting. Next thing, adding. Okay, let's go backwards. Subtract 3. The inverse of square rooting is squaring, and then add 2. So I go f inverse of x equals, take my number, subtract 3, square it, and add 2. And you go, I don't know if you're right, Miss Rifkin. Okay, take this and put it into the original, right there. Okay, so I'm going to go the square root of minus 2 plus 3, all of this. X minus 3 squared plus 2. Okay, so this went right in there for x. What's 2 minus 2? Gone. What's the square root of x minus 3 squared? Well, a square and a square root cancel. X minus 3 plus 3, x, y equals x, which is the line of symmetry. You know, you're good. 2, go. We know the points. And if this is the domain, it's, the domain and range for each. That's good enough. You guys get the idea. Okay, so they want you to prove down here, are they inverses of each other? So you can either take, let me zoom this in. You can either take this and put it in there. Or you can take this and put it in there. But since I did the first one in pen, I will do this. So I'm going to take all of this and put that in there. So I will go 5/3 times 3/5 x minus 15 plus 25. When I distribute this to this, cancel, 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 x. When I do this, 3 goes into 15 5 times, and 5 times 5 is 25. That cancels. Y equals x. Yes, this is the inverse of this. All right, let's do this one. Take this, plug it into here, or you can take this and plug it into there, but it doesn't matter. That's just what I'm going to do. So I'm going to go 2 over x plus 10 minus 10. Okay, well that's gone. So it's really 2 over x. Well, this means 2 divided by 2 over x. Well, remember when you're dividing, it really means you multiply by the reciprocal. 2 on top, 2 on bottom. Y equals x. Yes, they are inverses of each other. If you're stuck on this, just text me, okay? All right, let's do the next one. I could take this, plug it in here, or I could take this and plug it in here. I'll change it up a little bit. I'll take this and I'll plug it in here. So I'm going to go 4 square root of, oops, I don't know why I'm making it so small. 4 square root of x plus 10 minus 10 squared all over 4. Well, 10 minus 10, gone. 4 square root of x squared over 4. This is tricking you. I can't cross these off because of the exponent. So that would actually be 16. Then I can cross this off over 4, which is 4x. It does not equal x. No, it is not a function. Let me repeat it again. This 4 was with the squared. So if it's with the squared, I have to distribute it. I can't cross this off. This is inside a square. This is inside a parentheses that has a square, and this doesn't even have a parenthesis or a squared. I can only cross things off when they're both looking the same. I'll do this last one in the next video.